Hey guys, today I'll be showing you how to make a burning loading screen. Before we start, you'll need the free Dissolve Edge shader from the Unity store. I'll have a link for it in the description below. So to start off, I've created two simple scenes in Unity, Scene 1 and Scene 2. Let's go back to Scene 1 and take a look at the canvas. You should always have the UI scale mode set to scale with screen size. When I expand this object, you'll see that all we have is a button and some text. Now I'm just going to create a black image by going up to Game Object, UI, Image, then I'm going to change the color to black and scale it to size. I'm now going to add component and search canvas group. The alpha is what we'll be using through code to change the transparency, and we'll also be disabling block raycasts into interactable. Let's keep up with good file structure and create a folder called scripts. I'm now going to create a new C# script and call it load screen. I'm going to create a private canvas group called load canvas. Since we're attaching the script to the top of the load image hierarchy, I can just do load canvas equals get component canvas group, which will get the object for me. We're now going to create an IEnumerator called fadeIn. IEnumerators are great for fades because they'll only run once and alongside the update function. Once the fadeIn starts, we'll stop the game world time to ensure nothing happens to the player, while the loadCanvas.alpha does not equal 1, which means that it won't stop running until the canvas is fully faded in. LoadCanvas.alpha equals mathf.move towards loadCanvas.alpha 1 time unscale delta time. Unscale delta time is very important since delta time relies on the time scale. And lastly, yield return null. We're now going to create our load scene function. The on-click events don't seem to work with IEnumerators. To start a coroutine, we type in start coroutine fadeIn. Drag the load screen script onto the top object. Click your button and add an on-click event, and drag in the object that has the script on it. Now open up the drop-down. Under load screen, select the load scene function. Let's press play and check out how the fadeIn looks. Now let's create our loading screen. We'll go to Game Object, UI, Image, and drag your sprite into the sprite box. I'll turn the alpha back up to 1 to see what I'm doing and rescale and center the night. Under Material, select the matte_dissolve edge material. It comes with a whole bunch of options. Progress refers to how burnt it is. This dissolve texture is actually one that I made to get it to dissolve from the edges inward. To make this texture, open up Photoshop and make a 1024 by 1024 template. Make sure you have your brush color set to black and white. Now go to Filter, Render, Generate Clouds. Make a new layer and select the Gradient tool. Drag up from the middle, set the blending option to screen and turn the opacity down to 70. You may need to adjust the settings here, or you can just copy what I have. I'm just going to turn the opacity down on everything so we can see the main canvas. So now we're going to create a few new variables. Serialized field, private image, load image. Using a serialized field allows us to access private variables in Unity. We'll also need the Unity engine.scene management. Create a private async operation. We'll just call it async operation. And two floats, one called burn progress and one called progress. Let's create an IEnumerator called async load. It'll take in one string name. So to start loading, all we have to do is make async operation equals scene manager.load async along with the scene to load. Burn progress equals 1, load image.material.set float, and we'll give it the string name of _progress because that's what the variable we want to change in the shader is called, along with burn progress as the float value. We can get the shader variable name by opening up the shader code and finding the variable name in there. Since the player is already waiting at the loading screen, we might as well call our garbage collector. This would also be a good place to save the player's game if you needed to do that. So for some reason the progress only goes up to 0.9. So to keep it in the loop, we'll do async operation.progress does not equal to 0.9f. Let's change the progress shader variable by doing burn progress equals methf.clamp01 burn progress minus 0.5f times time.unscaled delta time. We'll now set the new value with loadImage.material.setFloat progress burn progress. And progress equals methf.clamp01 async operation progress divided by 0.9f, which will make it go up to 100 for a better accuracy and readability. And let's not forget about yield return null. We now need the load scene function to take in a string to load the wanted scene, which will also go into the fade in coroutine. After the loading screen fades in, we need to call the async coroutine to start loading. Let's select the new function and type in scene2. Before we press play, we need to go into our scene2, go up to File, Build Settings, and add the open scene. If you don't do this, the scene won't load. We'll now go to scene 1 and press play. So as you saw, it loaded super quick and you didn't even get to see the loading screen. Let's change that. In your script, set async operation.allows scene activation to false. Below the while loop, set async operation.scene activation to true, and since we're done loading, we should set time.timescale back to 1. Up in our while loop, we'll add or burn progress does not equal to 0, which ensures that the burn animation plays through fully. We should change the speed of the burn rate depending on the loading progress. This will stop the burn shader from burning too fast and leaving the player with a black screen. But we need to make a burn rate float variable first. So let's go back down. Burn rate equals 0.05f. Else if progress is greater than 0.5 but less than 0.9f. Burn rate equals 0.2f. And lastly, burn rate equals 0.5f. Let's get rid of our hard-coded variable and replace it with burn rate. We'll now move the burn image set into the fade-in coroutine and set load canvas interact and block raycast to true so that it blocks mouse interaction. Let's drag our image with the sprite onto the load image slot and press play. So the image burns in, then burns out. We only want it to burn out. We'll get to that in a minute, but first let's make a nice fade out into the next scene. Open up scene 2 and create a new image, scale it up and make it black. I'm now going to create a new animation by going to Window, Animation, Animation. Create a new animation clip by clicking Create. And again with folder structure, let's create a folder for animations. Don't forget to press record, go to the color and set the alpha to 1. Then go to 1 second in and change the alpha to 0. We'll also enable and disable the image since we don't need to see it. Let's open up the animator by double clicking it. Click on the animation you just made and set looping to false. Let's test it to see how it looks. Awesome, the fade out works. Let's take care of the burning issue now. In our script, we'll make a serialized field, private material called burn material. In our fade and coroutine, we'll make the load image material equal null. And for the final line of code, in the async coroutine, make the load image material equal to the burn material. In our scene, set the burn material to be mat_dissolve edge, and that's it. You now have a nice burning loading screen. This tutorial was made to help promote my college group project, The Fallen, which will be at Level Up Ontario in April. If you want to keep up to date with our progress, or for more tutorials, I'll leave a link to our Facebook page below.